We got another piecewise function, big surprise, and we see that g has three pieces, 2x minus 5, x cubed minus 2x, and gasp, a logarithm. Oh no. So, we're going to answer some questions about the limits, and the first one is the limit as x goes to -1 from the left of g of x. Well, that means that x is approaching -1 from numbers below -1, like -1.01, -1.001. Think about a number line. All right, here's -1. Numbers less than -1 are up here, and they're a little bit less than -1. So again, -1.001. And they're moving in towards -1. That's fine. Well, that means we're in this domain. X is less than -1. And as x approaches -1 from the left, well, we're on this graph. So any value less than -1, if I want to know what g is there, I plug it into 2x minus 5. Which means as x approaches -1 from the left, g of x is approaching what 2x minus 5 equals. And that is -7. As x approaches -1 from the right-hand side, now we're in this domain. So, as x approaches -1 from the right, it should equal what this thing is headed towards. And when you plug -1 into here, you get -1 cubed is -1. Do it here. So -1 cubed minus 2 times -1 is -1 plus 2. That's 1. Oh, we got a text message there. Since the left-hand limit is -7 and the right-hand limit is 1, that means on this graph, even though I might not know exactly what's happening the entire time, I know that -1, this graph from the left side is approaching -7 way down here. And from the right side, it's approaching +1. And it actually equals it from the right side because at -1, this is where x is equal to -1. I can plug it into here. So this is what this graph looks like. It jumps from -7 up to +1. Since that happens, since I can't zoom in on -1 and close all those y values because there's some up here and there's some way down here, this limit does not exist. My graph's not going to the same place on both sides. Okay, the limit as x goes to 2. Now I'm not even asking about the left hand and the right hand limit. I'm just asking about 2. I'm skipping all the nonsense with the left and right hand limit. But since my function splits at 2, I need to check both sides here. I need to check and see what's happening to f of x from the left and the right of 2, or g of x, I'm sorry. So even though they're not asking me this question, not g, even though they're not asking me the left hand limit, I need to investigate it. And I also need to investigate the right hand limit. Okay, there we go. As it goes to 2 from the left, we're on this domain, x is less than 2, and that means we should be on this function, and this function is approaching 8 minus 4, which is 4. Okay, so the left-hand limit is 4. As we approach 2 from the right, we have values bigger than 2, so we should be on log base 2 of this, x squared plus 6x. When x is 2, this function here equals, let's write this out, log base 2 of 16. Well, that says 2 to what power is 16? Well, that's just 4. Since the left-hand side is approaching the right-hand side, so let's check this out, +1 and +2. We have 2, 3, 4. All right, the left side is going to 4, the right side is going to 4, and that means both sides are approaching the same thing. So if I zoom in on that, on my x values, that means I'm going to zoom in on 4 as well. So the limit exists, and it's 4. Is g continuous at -1? No, you can see from the little graph here, it's going from -7 to +1. It's jumping, so no. Is g continuous at 2? Yes, because at 2, the function equals 4, because you can plug, this is when x equals 2, you plug it in here and you get 4. And, so that means there's a dot here, and the left side is approaching 4, and the right side is approaching 4. So we get this little thing going on here. It's continuous all the way through 4. It doesn't jump, it doesn't skip over anything. Yes.